Hi, it's Jocelyn. So it is crazy, but we are already halfway through Advent of Code. December is just going by so fast. So yesterday I just couldn't upload a video for day 13, but I'm going to go over how you might arrive at a solution, some of the mistakes I made while doing it, that kind of thing. So to start with, we download our input. We see a bunch of points, followed by an empty line, and then some folding instructions. That's right, we are doing origami. So the points represent dots on a transparent paper. Somewhat confusingly in this visualization, the dots are represented by pounds, and the dots in the picture are just like empty spaces. And then at the bottom there are folding instructions. For the first part, we are just looking at how many dots are visible after the first fold instruction. It's bolded, so I missed that when I was going through it the first time, but there we go. Let's see how you might do this. So first of all, I'm going to move this out and call this lines, and then we'll try doing this. So for line in lines, if the line is empty, then we're going to break, because that means we've arrived at the second section, and then we will continue to the second section and look at the fold along sections. So let's see if this works, if we can continue using it later. It can't, because this moves it. So we have to be a little bit more clever than that. What we can do instead is do while let some line equals lines dot next, and then this will just like slowly eat through the lines without like actually moving it, and then we can use it here. Anyway, apparently this works just as well. All right, wonderful. Clippy in Rust is truly magical. So secondly, now we're going to just start parsing the lines, so parsing the points. We're going to use a hash set for that. So points equals hash set dot new. Rust has a handy function called split once, so we're going to use that. So xy is equal to line dot split once, and that's split once on the comma. Dot unwrap, just to make sure we actually have something. And then we're going to say points dot insert, and then our y coordinate and our x coordinate. That's just the direction I always do it. All right. So we should probably give this type. Oh, these need to be parsed. And this type's now unknown, so we just need to give a type. I like being able to use negative numbers even if I'm not going to, so it'll be I64, I64. Great, now we have our points, and we need our folding instructions. We're actually just going to break after the first folding instruction, because, as the instructions say, we only care about the first fold instruction for part 1. So here we can split once on fold along space just to get rid of the fold along. So I'm just going to call it the instruction equals line dot split once fold along dot unwrap, and then we're going to do the same to get the actual instruction. So that is the axis and the position is equal to instruction, again dot split once on the equals, and we're going to unwrap that. And now the instruction, or now what we do, depends on whether we're splitting along the x-axis or the y-axis. So we're going to match the axis, and it can be x or it can be y. And if it's anything else, then we made a mistake. So then we'll just panic. All right, so how do we actually split? This to me is the tricky part. The tricky part of the puzzle, because I'm just terrible at geometry. So here it gives us a nice example for if it's along the y-axis. So if it's along the y-axis, let's see. It's along the y-axis, then like this is just along the y-axis, and it's we're folding these up there. So all the x coordinates stay the same. Some of the y coordinates, or the y coordinates below the split, change. I'm just going to remove this break just to simplify this a little bit. So let's start with the y-axis example, just because we have this first. So I'm going to actually create a new points variable. That is another hash set. And for points, which is just for yx, in points.iter, we're going to add those two new points. So new points dot insert. We said the x coordinates don't change. The y coordinates might change. They don't if y is less than the point that we're splitting with. I'm actually going to call this split. If y is equal to the split, then we've made a mistake, because the instructions state that it can't actually split you will never split on that axis, like on the axis. So in that case, we'll just panic. And otherwise, y is bigger than the split. So if we are one line below the split, we want to eventually be one line above the split. If we're 2 lines below the split, we want to move to 2 lines above the split, and so on. So for 1 line below the split, how do we say that? That is just y minus the split. Before I forget, these are references. They should actually just be values. Okay, but that's how many below the split it is. We actually want it to be above the split, so what we actually get is then split minus that. And I think that's right. We'll find out if I remembered correctly. Okay. And again, it looks like we need more references. Oh, yeah, also split needs to be also in I64. This is saying this can be rewritten as a match. That seems a bit messy to me. I'm just going to rewrite it as this to get rid of the warning. I think that's clear enough. And otherwise, the X section is going to look really similar. We also need to remember to say points equals new points. The X is going to be really similar. We're just going to split. We're just going to replace our X and Y's. So something like that. Okay, so I definitely want to try the example for this one. It's a little bit tricky. I could have missed something. So I'm just going to run that. And the actual answer will be the number of dots which are visible, which in this case is 17. And we're actually just, like I said before, we're just going to use the first iteration. This is going to give us a warning, but I figured that won't be the case in part 2. So now we're just going to do points.len, and this is actually a U size, not an I64. Alright, so right now we're getting an explicit panic, it says. And that is at line, let's see. First of all, I just want to turn off part A. And it's saying the explicit panic is happening on line 24. And this is because we need to use an X, not a Y. I just forgot to replace that. Okay, the first example is right, so let's see if we get the right answer for part A. Okay, it says the answer is 720, and that is indeed what we got. So now we can move on to part 2. Part 2 is similar to part 1, like it's not a different problem. We just unsurprisingly need to loop through all of the instructions and then actually figure out what text is written in the output. So for this, I'm not going to actually make a new function. I'm just going to call this solve now and have it return the answer to part A and part B. I'm not going to try to parse the output or like parse the ASCII art. I'm just going to return it as a string. So what does this look like? We're going to make a variable called part A. And we're going to enumerate this. I'm going to call this I, index. And if we are on the first index, we're just going to store the length of the points. So that is part A equals I. We're no longer going to break. And now we can return the first part, which is part A, but we also need the message. So what is the message? We need some way of printing it. So for that, what we're going to do is we're going to find the start line, the end line, the start X position, the start Y position, and we're going to find the min and max Y and X, and then we're going to iterate through those and print a dot if there's not a dot, and print a hash sign if there is a dot, just like an example, and we're going to return that as message. So let mute message equals a new string, and min X is going to be points dot map, I guess dot there, dot map. Going to return X, and we're going to get the min, and we're going to unwrap that. And there are 3 similar things. So we have min X, max X, min Y, and max Y. And these 2 are Y, and these 2 are max. And now we should be able to iterate through it. So for Y in min Y to max Y, so to be careful here, we need to make sure that we include max Y. It's not a length, it's the last Y. And then same for X. And then we're going to say if points.contains, and like the point we're looking at, so that's just YX, then we're going to, as we said, push a ampersand, and otherwise we're going to push a dot. At the end of each line, we're going to push a new line, and then we can return that. Okay, so like we said, rename this to solve. And I'm just going to do an empty string dot toString, and same over here. And this will give us, let's see. Oh yeah, this warning is valid. That just makes it a bit clearer. Okay, so here we have our outputs. It's not particularly legible like that, so I'm just going to copy this into our code and make it a little bit more legible. So the way I'm going to do that is, because of the formatting, REST format, there's not a great way to like actually start this on the next line. So I'm going to say .trim start, which will just remove that new line at the beginning, and then I'm going to replace the new line with actual new lines. And you can see, as the example said, it is a square. And based on the way we made this, we expect a new line at the end, so we're going to leave that in. And we're going to do the same for this. All right. And that sure looks like some text. So first of all, we just see that, our example there failed. What did I forget to do? Or what did I mess up here? I'm just going to try copying this again. First of all, just by copying exactly what I did, see if that passes. What did I do wrong? Oh, what I did wrong had nothing to do with the string. It was just that we're return that it's a mistake here. Instead of, I said part A equals I, that was just kind of like a brain fart. What it should have been is points.len. All right, and they both pass, and we see that the output here, or the answer here, is this, AHPRPHUZ. Wonderful. Anyway, thank you for watching, and see you tomorrow.